Okay, my name is Ihsan, and I'm a research fellow at CeADAR at TU Dublin, and I'm going to present XPlainIT, which is for Explainable Artificial Intelligence. Dr. Susan McKeever is the project investigator, and Mr. Andre is the software engineer, and Mr. Webb is the intern who contributed for completion of the demonstrator. These are the list of interested companies who has shown interest in the XPlainIT or Explainable Artificial Intelligence demonstrator. Machine learning or deep neural network has shown promising results throughout the last few years, not only in one area, but in various application areas with input as images, text, signal, or structured data. That results in output in the form of a label, segmented image, real values, text. Despite that, deep neural network has shown good results or being in taken acceptance across many organizations and domain. Still, they are considered as black boxes. And various question arises about their transparency of the model, understandability, how to gain insight from the whole data set or from each individual decision, why one prediction is made over another, and how these predictions are made. So to answer or to make the black box explainable or transparent, explainable artificial techniques like clear-wise relevance propagation, Shapley additive explanation, and local interpretable model agnostic explanations that Oshin and Lewis mentioned a while ago, they have been addressing the issues of the black box decision making, allowing them to be transparent and understandable. And here you can see some examples of those application areas where they have been utilized, for example, for object recognition, text, speech, games, visual question answering, or medical areas. In various areas, these have been applied in order to get answers. But from the literature review, we have found that they were not being used for structured data, or as a while ago, she mentioned that layer-wise relevance propagation is being used with deep neural networks rather than with the traditional machine learning techniques. So what we proposed in the explainable artificial or XPlainIT demonstrator is to use deep convolutional neural network with structured data, which is not very common, and with the explainability technique of layer-wise relevance propagation in order to explain how a deep convolutional neural network will work with structured data and how they will take decision. For example, it might help us in answering why is this customer predicted as at a risk of churn, for example, if it is related to a telecom churn data set, or how this answer has been influenced, or can this system provide textual explanation to the end user or the customer, or can it provide help to the data scientist in understanding how can they improve the performance of the deep neural network, or can we have some sample test in changing some input feature that can help us in understanding the output or the confidence of the network, or how or which feature can change the result from yes to no or no to yes. So we have added these features in the explainable demonstrator that will help the user in understanding about the deep neural networks, as well as about the some textual explanation that could be helpful for the companies. So this is the overall architecture of the XPlainIT demonstrator. We have an offline stage where we have used telecom customer churn and credit card data set that are being used to train the 1D convolution neural network. Once it is trained, we provide the deep network and the testing set to the demonstration stage, where we provide some general information about the data set and about the model being trained. And then those are used to visualize or provide explanation in terms of local interpretation, global analysis, and for a new record analysis. So we will show you these later in the demonstration. Here, just to give you a quick overview of the demonstrator, this is the home page of our demonstrator, where you can have some background information as well as some tutorial that can help a user how to use the demonstrator. You can select a data set and then you can start, which will bring you to the main page. On the main page, you will have some statistical information about the data set, some that can help let you know what type of feature this data set has. We have used two data sets from Kaggle, which are freely available, telecom customer churn prediction and credit card fraud detection. So we will explain or demonstrate with those two data sets. This is a view for the local interpretation. I will not go in detail right now, but when I will be demonstrating the demonstrator, then we will discuss each of these features. But you can see that it can provide you the confidence level of the classifier, the predicted values, the input values, the heat map, which shows the important feature in for each individual classification decision. And this information could be helpful. For example, the textual information could be helpful for the end user or customer, or the heat map could be helpful for the data scientist and company. We also provide the global analysis of which can be helpful for the data scientist or the companies, for the data scientists in terms of, for example, to see how the false positive and false negative can be reduced. For example, it provides a plain pattern of the important feature for example, in this case, for the true positives. You can clearly see that the monthly contract, fiber optics, monthly charges, paperless billing, and phone services are some of the important features that have been highlighted and that are common throughout the decisions for true positives. So this can help the data scientist in improving the performance, as well as for the companies to retaining the customers. As I mentioned, pattern is important, or important feature are important for data scientists. That could be helpful. And here you can see a new record for where a user can change certain input values, and in real time, layer-wise relevance propagation and the deep neural network is applied on it, and the important features are shown. And we will also show how LRP is faster compared to Lime and SHAP in the demonstrator. So how CeADAR member companies can benefit from XPlainIT? It is a web-based and easy access with friendly graphical user interface. It provides insight to the companies. For example, if there is an financial organization who provide loans and an applicant or customer apply loan application, it can provide the textual explanation in case or if her application is rejected, why his application is rejected, what were the main reasons, top 3 or top 5 reasons that because of which his application is rejected, how he can improve, for example, his credit score, or later, if that's one of the reasons, how he can improve it, and then he can apply again and he can get the loan. It can provide insight for the companies to be GDPR compliant. In a case, for example, data scientists can see whether it is biased or not. So that could help them. It can help the company as well in retaining the customer by identifying, for example, we will see in the telecom customer churn data set example, that if we redo, sometime the customer will mainly churn if it is a month-to-month contract and the monthly charges are high. So by reducing the monthly charges and providing them a yearly or a 2-yearly contract, they can retain the customer. and it is said that retaining a customer is better than having a new customer. So it can provide insight of how to retain the customers. It can also help the data scientists in improving the performance of the deep neural networks. For example, the deep convolution neural network, how the false positive, or what are the features that are creating or generating false positive or false negatives. How can they improve it? And this demonstrator finally can be a baseline for understanding of explainability by the companies that we can then discuss, and through innovation vouchers or IPP opportunities, we can enhance it for their own specific purpose, and we can utilize it for that reason, for the companies to work with us. So the question could be asked via email. I will now go to the demonstrator to show how it works. So this is the main page. Here you can see the background information. You can have a tutorial, video tutorial. You also have a PDF tutorial that you can use for understanding how it can be used. You can select a data set, click start, and it will load it. Here you can have some explanation about the models used or the algorithms being used in this demonstrator, about the data set details, how many records are there currently. For example, what algorithm we have used for balancing the data that we use small. You can read about individual features in the data set, their statistical analysis. Just to highlight, there are only 3 non-categorical features in this data set. The rest are all categorical. And this telecom customer churn data set is divided into 73% of non-churn records and 26% of churn records. The credit card fraud is highly imbalanced. It is 99% for normal transaction and less than 1% for fraudulent transaction. Now we will go to the local interpretation. Here you can see details about what local interpretation for a singular instance means. We are highlighting or showing the result of one singular instance in the testing set. In the testing set, you have 1407 samples that you can play with, or you can change it by changing in the slide. And then you can see their input details here. This is the features. These are the normalized values and the original values in that specific. Currently, for example, for the record 1. You can minimize this. Then here you will see 3 types of explanation: LRP, LIME, and SHAP, that being previously mentioned as well. You can have a definition and the color code scheme for each heat map for the LRP, LIME, and SHAP in this tab. We have the textual explanation that will be generated after each record is being processed. For example, in this case, it is mentioned that the customer will abandon the business because of tenure, phone service, and streaming videos. So these were the top 3 features that were highlighted. But in addition, there is contract month to month and total charges and streaming movies are some other features that have been shown that they are also highly valuable for retaining or to identify that the customer will churn. We will see in the new record analysis, if we change one feature, how the confidence level of the classifier changes and how these feature changes. You can have the LIME visualization for important feature. Orange bars shows that these is fiber optic internet service contract are the supporting feature in terms of the decision towards churn, and the blue are the features that contradicts towards the decision. We also showed Shapley, where you can have the information about them and Here you can see that those, what is the color scheme? The dotted green line are the base value, dotted black line are the model output prediction, red arrow shows the features that push the prediction higher to the right, and blue arrow are the one that push the prediction lower to the left. So this was the visualization of the important features for individual case. Now we can have the visualization for the whole data set or the subset of the data set. For example, by the subset, I mean considering only the true positive and understanding what is the pattern of the important feature. For example, in this case, the pattern, the important features are phone service, monthly charges and contract month to month, or fiber optic for the true positives. For true negatives, it changes. For false positive, it is completely slightly far more random. And same is for the false negative. So a data scientist can learn from this that how we can further improve the performance, whether if there are some features that are unnecessary, we can remove them. And here we can see the whole visualization of the whole testing set. Same is the case for Lime in SHAP. For the SHAP, we also provided the Boxplot because that's one of the common use with SHAP. So to show some additional features, here you can select and deselect, and it will show you the important features that show the highly relevant features for this scenario or for the whole data set. What are the important features that are contributing most towards the positive scenarios or toward the true positives. Now coming to the last feature that we have added, it is about changing the values and applying the deep neural one-dimensional convolution neural network on it, and then visualizing the important features with the layer-wise relevance propagation technique for explainability. So these are the features that have been shown on the main page. These are for the telecom churn. If there is another data set, or if the data set is provided by the company, these will be according to those. So we can change, for example, the features, and in real time, it will change the decision of the model. For example, currently we said we have seen that contract month to month was an important feature for the decision towards true positive. So we will try those. For example, a fiber optic was also an important, and as we have changed, you can see the decision has been changed. And now I will also show that with each change, you get different type of features. So, and the same is the case for Lime and SHAP. But now we will show that how LRP was in real time, whereas Lime takes around 15 seconds. You have to click, and then you have to wait for about 15 seconds to process. The same will be for the SHAP. It is far more time consuming than LRP and Lime. It is around 50 seconds. You can have some information about the Lime technique and the color code. We also showed that the confidence level is how confident the system is over the classification. And here, as you can see, it predicts what are the important features that are shown in orange bar. For the SHAP, if you click, it takes around 50 to 60 seconds to process. So LRP not only is faster, but it is also being used with the deep neural network, like 1D convolution neural network, that could be helpful for the structured data. And normally, nobody uses convolution neural network for structured data, but as there could be correlation among the features of a structured data, and convolution learns the correlation by the sliding window approach. So this could be helpful, and that shows good performance, as well as highlights the important collaborative features that result in a decision. So as you can see, it takes time. So the last tab is for the tutorial that one can use and understand how to use this demonstrator. The rest is the same. So this could be really helpful for the data scientists in terms of identifying the important feature. The textual explanation that we have shown before could be helpful for the company to give as a result of acceptance or rejection of an application. In the same time, the global analysis could be helpful for the law enforcement agencies or the companies to check for the GDPR compliance. That's all from my side until this SHAP finish. Thank you for listening and watching.